So today we've been asked to graph y equals 3 cosecant 2x. And cosecants and secants are funny little graphs, and I like to think of them very much like if you can graph sine and cosine, you can graph secant and cosecant. So, and I always teach my classes, when you see cosecant, when you see that, you need to think sine. Okay? You need to think sine. And so what I want to do is I just want to, in this green color here, I want to graph y equals 3 sine of 2x. 3 sine 2x. And you have to know what these numbers mean. This is your amplitude term, and this is your period modifier, a and b. This means you're going to go to a maximum of 3 and a minimum of -3. And this is going to be a horizontal change, either a stretch or a shrink. And the way to find that is to know that the period of a sine graph, is 2 pi over b. 2 pi over b. And 2 pi over b is going to be 2 pi over 2, which is just pi. Okay? So what that means is you're going to start at 0, and you're going to go up and down and back up to 0 in pi units. That's what that means. That's how long it's going to take you to complete one wave. And that wave is going to be 3 units tall above the axis of symmetry, and it's going to be 3 units tall below the axis of symmetry. And of course, the way a sine graph works is it goes up, back through the line of symmetry, down, and back through the line of symmetry. So it's going to go back through the line of symmetry right between those points. The maximum will occur here, and the minimum will occur here. It's going to go up and down and back up. Now, and it's going to keep doing that. So that's 0 to pi. And for 2 pi, it's going to do the same thing. It's going to go up, and it's going to go down, and it's going to go ta-da, back up, back down. And we could keep drawing this over and over. It's very repetitive. This is not my answer. This is my sine graph. Okay? The way a cosecant graph works is cosecant is 1 over sine. Okay? Cosecant is actually 1 over sine. Okay? And so something magical happens here. The value of sine is 0 here. The value of sine is 0. Okay? And so 1 divided by 0, that's undefined, and you should have learned in algebra that gives us a vertical asymptote. And so at every one of these zeros, you're going to get a vertical asymptote. Okay? So a vertical asymptote. Every one of these little guys is going to give you a vertical asymptote. And we could keep doing this, but I think you get the picture. That's enough. Okay? And what happens with cosecant is cosecant and sine are equal at the peaks and the valleys. Cosecant and sine are equal at that point, okay? And cosecant is, they're not parabolas, but they kind of look like parabolas. And they come from the peaks and the valleys of the sine graph, okay? And so if you were to graph this on a graphing calculator, this is what you would see. What's in red is my graph. This is my graph. Okay? It's these little parabolas that come off the sine wave. And of course, normally, if you were trying to do this and make it neat, you would do it in pencil, and you'd go back and you'd erase what I've done in green. You'd just erase that sine function. It would disappear from memory. And so I tell people, if you know how to graph a sine function, you can graph a cosecant function. Go ahead and just graph the sine function, and at every peak and every valley, you just draw a U-looking, kind of a parabola-looking thing, and you put in your asymptotes. Same thing is true for secant and cosecant. If you can draw, secant and cosine. If you can draw the cosine graph, the secant graph is just going to be parabola-looking things that come off of each peak and valley. So if you have any questions about graphing secants or cosecants, please let me know.